which before we discuss, all the questions are in factorials format. Now first we'll define what is a factorial. What is a factorial? Assume this question is not there. This question is not there. Factorial. Factorial means n factorial is nothing but product of all consecutive integers starting from n to go backwards till 1. Factorial is nothing but product of all consecutive integers from n to 1. Start at 5. 5 factorial means 5 into 5 into 4 into 3 into 2 into 1. If it is 4 factorial, 4 into 3 into 2 into 1. Start from n and go back till 1 onwards. Product of all consecutive integers from n to 1 is nothing but the factorial. This is a mathematical way of putting it, the factorial and exclamatory symbol. Suppose if it is 4 factorial, it is 4 into 3 into 2 into 1, which is 24. If it is 3 factorial, which is nothing but 3 into 2 into 1, which is 6. If it is 0 factorial, it is nothing but 1. 1 factorial, it is also nothing but 1. 0 factorial is 1. What do you mean by 0 factorial? Are you listening to the class? Your answer will be either yes or no. 0 factorial, whether it is existing or not existing. Your answer will be a unique value, either yes or no. So the answer will be 1. So n factorial is nothing but n into n minus 1 into n minus 2 into and so on up to 1. These are all the product of all positive integers from n minus 1 to 1. So these is nothing but n into n minus 1 factorial. N factorial is also given by n into n minus 1 factorial. N factorial is also given by n into n minus 1 factorial. That means 4 factorial can be written as 4 into 3 factorial, which is 24. 5 factorial is given as 5 into 4 factorial, which is 120. 6 factorial is given as 6 into 5 factorial, which is nothing but 720. 120 into 6. Factorial is defined only for whole numbers. Factorial is defined only for whole numbers. Factorial is written as n into n minus 1 into n minus 2 till 1. 4 factorial, these is very important. 0 factorial is 1 and 1 factorial is 1. These is also something which we are going to use it. N factorial is n into n minus 1 factorial. N into n minus 1 factorial. Another important observation in this concept is, suppose for example, if I take this value, listen carefully, sir. N factorial, or I will take like this, 4 factorial by 3 factorial. It is nothing but 4 into 3 factorial by 3 factorial, which is nothing but 4. That means n factorial by n minus 1 factorial, which is nothing but n, which can be deduced from here also. N factorial by n minus 1 factorial is always n. N factorial by n minus 1 factorial is always nothing but n. These also we are going to use it in few problems. N factorial by n minus 1 factorial, it is n. In the first slide we discussed the definition of a factorial, how to find out the value of a factorial, and what are the important key points with respect to a factorial. N factorial is n into n minus 1 factorial, and 0 factorial and 1 factorial will give you the same values, and the value is 1. Now let us solve some problems. First question, n factorial is nothing but 3 factorial into 5 factorial into 7 factorial. What is the value of n? One way to find it is find out the values of factorial and check which factorial equates that value. You don't do that. 3 factorial is 6. 5 factorial is 120, which is nothing but 7 factorial. So these are nothing but 10 into 6 into 12 is 72. into 7 factorial. So n factorial is 10 into 72 is 9 into 8 into 7 factorial. So 10 into 9 into 8 into 7 factorial. 7 factorial is nothing but 7 into 6 into 5 and so on up to 1. Product of all the integers from 10 to 1 is nothing but 10 factorial. So what is the value of n? Value of n comes out to be 10. Value of n comes out to be 10. I hope the idea is clear. N factorial is 3 factorial into 5 factorial. 3 factorial is 6. 5 factorial is 120. 6 into 120. 6 into 12 is 72. 72 is 9 into 8. 10 into 9 into 8 into 7 into and so on up to 1 is n factorial is 10 factorial. So the value of n comes out to be 10. I hope the first question, basic question on factorials is clear to you. Next one. Very, very good question. How many of the following 99 integers are prime numbers? 100 factorial, 100 factorial plus 2, 100 factorial. Can I say 1 factorial is 1, 2 factorial is 2 into 1, 3 factorial is 3 into 2 into 1, 4 factorial is 4 into 3 into 2 into 1. Just by seeing the question you can say it. 100 factorial by 2. 100 factorial is an even number. Why? Because 100 factorial is 100 into 99 into 98 and so on up to 1. 2 is also an even number. Even number plus even number is an even number. There is no even number other than 2 which is a prime number. So the first one is not a prime number. 100 factorial plus 3. 100 factorial plus 3. 100 factorial is nothing but 100 into 99 into 98 into and so on up to 3 into 2 into 1. If you observe 100 factorial contains 3. These also plus 3. 100 factorial is divisible by 3. 3 is divisible by 3. If I add two numbers which are divisible by 3, answer will be divisible by 3, or in other words it is a multiple of 3. In other words, it is a multiple of 3. Any number which is a multiple of 3 will be a composite number, will never be a prime number. 100 factorial plus 4. 100 factorial plus 4. 100 factorial is an even number. 4 is also an even number. Even number plus even number, it is an even number. There is no even number other than 2 which is a prime number. So 100 factorial plus 4 is there. 100 factorial plus 5. 100 factorial contains 5. That means it is divisible by 5 plus 5. 5 is also divisible by 5. 100 factorial is divisible by 5. 5 is divisible by 5. If I add two numbers which are divisible by 5, answer will be divisible by 5. Is there any number which is divisible by 5 other than 5 which is a prime number? Not possible. Last case, 100 factorial plus 100. 100 factorial is an even number. 100 is also an even number. Even number plus even number is an even number. There is no number other than 2 which is an even number and a prime number. So how many of the following 99 integers are prime number? None of the numbers. All 99 integers. All 99 integers are a prime number. Excellent, very, very good question which combines the definition of a prime number and adding two numbers which are divisible by another number. If I add two numbers which are divisible by 3, answer will be divisible by 3. If I add two numbers which are divisible by 5, answer will be divisible by 5. That concept I used it. Second question, a basic question but a very good conceptual question. I hope this question is clear to you. Third question. Third one, same idea. How many of the following 36 integers are a prime number? 37 factorial plus 2. 37 factorial is nothing but 37 into 36 into 35 into and so on up to 3 into 2 into 1. That means it is an even number. This is an even number. 2 is also an even number. Even number plus even number is an even number. Same idea, there is no even number other than 2 which is a prime number. First one clear, right? There is a small error, I think. How many of the following integers? Next, I think this is not 100 factorial. Previous question typo error. 37 factorial plus 3. These is divisible by 3. Here also it is divisible by 3. Answer is nothing but a multiple of 3. Answer is nothing but a multiple of 3. And so on up to 37 factorial plus 37. These is divisible by 37 and 37 is also divisible by 37. If I add two numbers which are divisible by 37, answer will be divisible by 37. So again it is a multiple of 37. That means all the numbers, these 37 factorial. Typo mistake. All are multiples of 37. Answer is no value. All the 36 integers, no value is a prime number. All the 36 numbers are composite numbers. I hope the idea is clear. Very, very good question which tells us the definition of a prime number. What happens if you add two numbers which are divisible by a particular number? Next one. Good questions are exam model question. 10 factorial plus 9 factorial into 8 factorial plus 7 factorial. Suppose if I take 10 factorial plus 9 factorial by 10 factorial minus 9 factorial. The concept which is used in this question is n factorial is n into n minus 1 factorial. So this is nothing but 10 into 9 factorial plus 9 factorial divided by 10 into 9 factorial minus 9 factorial. 9 factorial common, 10 plus 1 is 11. 9 factorial common, 10 minus 1 is 9. 10 minus 1 is 9. 9 factorial it is over. So the value is 11 by 9. Similarly, 8 factorial plus 7 factorial by 8 factorial minus 7 factorial. N factorial is n into n minus 1 factorial plus 7 factorial. 8 factorial is 8 into 7 factorial minus 7 factorial, which is 7 factorial into 9 by 7 factorial into 7, which is 9 by 7. 9 by 7. That means if you observe, if it is 10 factorial plus 9 factorial, for 10 I got 11, which is 1. 9 exactly it is like this. 8 factorial I got 9. 7 factorial 7 is like this. So first it is 11 by 9 for this one. Next it is 9 by 7. Next it is 6 factorial means it will become 7 by 5. Next it is 4 factorial means it will become 5 by 3. Next it is decrease 2, decrease 2, decrease 2, decrease 2, 3 by. Decrease it is 1. I hope 9 9 clear, 7 7 out, 5 5 out, 3 3 out. Answer for this question is 11. Answer for this question is 11. I hope it is clear. Idea that is used in this question is n factorial is n into n minus 1 factorial. Very simple idea, very simple calculation problem, and this, if you observe the first two values, you will understand the pattern. Observation. Through sheer observation, you can do it. 2 decrease, 2 decrease. So keep on decreasing by 2. Idea clear? Next one. Very, very good question. 1 into 1 factorial, 2 into 2 factorial, and so on up to n into n factorial. First, we will discuss the concept. First, we will discuss the concept. This is nothing but summation because addition is there. N into n factorial. N value is ranging from 1 to 9. I hope it is clear. Summation. N equivalent to 1 to 9. Add 1 and subtract 1 into n factorial. Till here it is clear. So n plus 1 into n factorial is n factorial. N factorial minus n factorial. If I substitute 1, 1 plus 1 is 2 factorial minus 1 factorial. If I substitute 2, 3 factorial minus 2 factorial. If I substitute 3, 4 factorial minus 3 factorial. 9, 10 factorial minus 9 factorial. So plus 2 is cancelled by minus 2. Plus 3 is cancelled by minus 3. So minus means plus is there. So finally the answer is 10 factorial minus 1. So these is nothing but n plus 1 factorial minus 1. Extremely important conclusion. Summation n into n factorial is nothing but n plus 1 factorial minus 1. Summation n into n factorial is nothing but n plus 1 factorial minus 1. I hope it is clear. Extremely important concept. Next problem I am going to use this concept. Summation n into n factorial is n plus 1 factorial minus 1. That entire idea is just adding 1 and subtracting 1. Adding 1 and subtracting 1, you will get this logic very clear. Idea clear, right? N plus 1 factorial minus 1. Now, this question see here. N factorial, the definition of a factorial is given. P is 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial and so on up to 10 into 10 factorial. These are nothing but 11 factorial minus 1. Are you all with me? Why? Because just now we discussed n into n factorial is nothing but n plus 1 factorial minus 1, n equivalent to 1 to some x value, n plus 1 factorial or some n value, n plus 1 factorial minus 1. If you know this conclusion, it's an easy question. Method 1. Generally students will solve like this. Reminder 1. P plus 2 divided by 11 factorial. P plus 2 is 11 factorial minus 1 plus 2. 11 factorial plus 1 divided by 11 factorial. This cancelled. So what is the answer for this question? 1. The concept that is used in this question is n into n factorial. N into n factorial summation is given by n plus 1 factorial minus 1. N into n factorial summation is given by n plus 1 factorial minus 1. 11 factorial minus 1 add to 11 factorial plus 1. These both are consecutive integers. 4 divided by 3 remainder 1. 5 divided by 4 remainder 1. 11 factorial plus 1 divided by 11 factorial remainder is 1. This is the method 1. Method 1 is nothing but the usage of this concept n plus 1 divided by n plus 1 factorial minus 1. Method 2. Method 2. The question is like this. P is 1 into 1 factorial, 2 into 2 factorial and so on up to 10 into 10 factorial. Remainder 1. P plus 2 is divided by 11 factorial. It is ending with 10 factorial. Denominator is 11 factorial. So let us take some smaller values. 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial. If I take 3 values, it is ending with 10 factorial. Denominator is 11 factorial. If it is ending with 3 factorial, denominator is 4 factorial. Denominator is 4 factorial. So these remainder 1. 1 plus 2 2s are 4. 6 3s are 18. I hope it is clear, right? 1 into 1 factorial. 1 into 1 factorial, 2 into 2 factorial, 3 into 3 factorial. But here it is plus 2, remainder plus 2. So here it is plus 2 divided by 24. 24, remainder is 1. Because it is ending with 10 factorial, denominator is 11 factorial. It is ending with 3 factorial, denominator is 4 factorial. Idea clear? It is ending at 10 factorial, denominator is 11 factorial. It is ending with 3 factorial, denominator is 4 factorial. Or you can take by for smaller values, remainder 1. 1 factorial plus 2 into 2 factorial plus 2 divided by 3 factorial. 2 2s are 4, 4 plus 2, 6, 6 plus 1, 7. 7 divided by 6, remainder is 1. What you can do is, you can see these, what we are doing is the law of similarity. We are checking what is the behavior for 2 values, 3 values and everything. Then we are saying that all are similar. Law of similarity. I hope the idea is clear. Law of similarity. Now, next question. What are the possible unit digits for n factorial? N factorial are defined only for whole numbers. That is the first domain of n. 0 factorial is 1. 1 is the unit digit. 1 factorial is 1. 2 factorial is 2. 3 factorial is 6. 4 factorial is 24. 5 factorial is 120. 6 factorial is 720. From 5 factorial onwards, what is the unit digit? From 5 factorial onwards, unit digit is 0. Unit digit is 0. What are the other unit digits we got? 1 we got, 2 we got, 4 we got, 6 we got. 1 we got, 2 we got, 4 we got, 6 we got and 0 we got. These are the possible unit digits for n factorial. These are the possible unit digits for n factorial. Possible unit digits for n factorial is 1, 2, 4, 6 and 0. I hope the idea is clear. Possible unit digits for n factorial is 1, 2, 4, 6 and 0. Because from 5 factorial onwards, unit digit is 0. So previous cases I got different values. 1 I got, 2 I got, 6 I got, 4 I got. From 5 factorial it is 0. So the possible unit digits are 1, 2, 4, 6 and 0. I got the idea? 1, 2, 4, 6 and 0. Very good question to tell all the possible unit digits for factorial. Next, find the unit digit of the sum. Find the unit digit of the sum. 1 factorial plus 2 factorial. Previous question concept I can use it here. 4 factorial, 5 factorial, 6 factorial and so on up to 2016 factorial. From 5 factorial onwards, unit digit is 0. From 5 factorial onwards, unit digit is 0. That means 1 factorial it is 1, 2 factorial it is 2, 3 factorial it is 6, 4 factorial it is 24. Here it is 0. 1 plus 2 plus 6 plus 4 plus 0. 1 plus 2 plus 6 plus 4 plus 0. You don't need to do this. All the possible unit digits are for a factorial is 0, 1, 2, 4, 6. Just now we discussed. All the possible unit digit factorials are 0, 1, 2, 4, 6, 10, 12, 13. So answer is 3. Answer is 3. 0, 1, 2, 4, 6. 6 plus 4, 10. 10 plus 2, 12. 12 plus 1, 13. 13 unit digit is 3. I hope the idea is clear. All the possible, it is nothing but from 1 to 4 factorial, I will get a different unit digits. From 5 factorial onwards, unit digit is 0. 1 plus 2 plus 6 plus 4 plus 0 is, right, 13. Unit digit for 13 is 3. Idea is clear, right? Find the unit digit of the sum. Idea clear, right? 2 questions of the same model. Next one. Find the last 2 digits of the sum. Previous question we did unit digit. Now we will do last 2 digits. 1 factorial is 1. Last 2 digits, right? So I will write 0, 1. 2 factorial is 2. I will write it as 0, 2. 3 factorial is 6. I will write it as 0, 6. 4 factorial is 24. 5 factorial is 120, which is 20. 6 factorial is 720. I will write down here the values so that you will not get. 5 factorial is 120. 6 factorial is 720. 7 factorial is 7 zeros are 0, 7 twos are 14, 4. 8 factorial is nothing but 8 zeros are 0, 8 fours are 32, 2. 9 factorial is nothing but 9 twos are 18, 8. 10 factorial is nothing but 10 8s are 80, 0, 0. That means from 10 factorial onwards, last two digits are 0, 0. From 10 factorial onwards, last two digits are 0 zeros. So I hope it is clear. How directly I wrote 20, even the values are not given. What you can do is 6 zeros are 0, 6 twos are 12. What is the unit digit in 12? 2. 7 zeros are 0, 7 twos are 14. What is the unit digit in 14? 4. 8 factorial, 8 zeros are 0, 8 fours are 32. 32 is 2. 9 factorial, zeros are 0, 9 twos are 18, 8. 10 factorial, 10 eights are 80. So 10 factorial is 0, 0. So addition will be 1 plus 2, 3, 3 plus 6, 9, 9 plus 24, 33. 33 plus 20, 53, 73, 113, 133, 213. So the last two digits of this number is 13. I hope the idea is clear. Right? Again I am saying 0, 0, 0, 0, 0, 0, 0 till here. 10, 12, 13, 3, 1 carried, 2 plus 8, 10, 14, 16, 18, 20, 21, 2, 1, 3. So the last two digits of this sum is 13. Idea clear? Find the remainder when 1 factorial plus 2 factorial, 1 factorial plus 2 factorial plus 3 factorial and so on up to 2016 factorial divided by 24. Now if you observe, 4 factorial is nothing but 4 into 3 into 2 into 1, which is 24. 5 factorial is nothing but 5 into 4 factorial, which is divisible by 24. 6 factorial is 6 into 5 factorial, which is 5 into 4 factorial. That means from 4 factorial till 2016 factorial, all are divisible by 24. All are divisible by 24. All are divisible by 24. So the case that is left is 1 factorial plus 2 factorial plus 3 factorial divided by 24. I hope the idea is clear. So this is nothing but 1 plus 2 plus 6 divided by 24. 9 divided by 24. Answer is 9. Answer is 9. Idea is clear, right? From 4 factorial onwards, all are divisible by 24. 4 factorial is 24, 5 factorial is 24, 6 factorial is also divisible by 24. From 4 factorial, all are divisible by 24. I hope it is clear, right? What we'll do is, we'll slightly change this question so that it will be a little innovative thinking question. I hope it is clear, right? Now, suppose if the question is like this, 1 factorial whole square, 2 factorial whole square divided by 18. 1 factorial whole square plus 2 factorial whole square, 1 factorial whole square, 2 factorial whole square, 3 factorial whole square, and so on up to 2016 factorial whole square divided by 18. Now, let us see what is happening from 3 factorial whole square. 3 factorial is 3 into 2 into 1 whole square, which is nothing but 6 square, which is nothing but 36, which is nothing but 2 into 18. 3 factorial whole square is divisible by 18. 4 factorial, which is nothing but 4 into 3 factorial whole square. So these also divisible by 18. That means from 3 factorial onwards, all are divisible by 18. Remainder is 1 factorial whole square 1, 2 factorial whole square 2 square 4 divided by 18. 5 divided by 18. Answer for this question is 5. 4 factorial onwards, it is divisible by 24. 3 factorial whole square onwards, it is divisible by 18. 3 factorial whole square, 4 factorial whole square, and so on up to 2016 factorial whole square, all are divisible by 18. So first two, 1 square plus 2 square, 4. 1 plus 4, 5 divided by 18 is 5. Idea clear, right? Another one, find all the 3-digit numbers that equals to the sum of the factorials of their digits. There is a 3-digit number, a factorial plus b factorial plus c factorial. Now if you observe, 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120. Listen carefully, sir. 6 factorial is 720. 7 factorial is 7 into 720, 5040. Think logically. Suppose for example, if I take 7 value, if I take a value 7, can I say this will become 7 BC? This will become 7 factorial plus b factorial plus c. This is nothing but from 700 to 799. 7 factorial is 5040. 4 digit plus something cannot give a 3 digit. A cannot take 7. Can A take 6? Let us see. This will become 6 BC. So it will become 6 factorial plus b factorial plus c factorial. 6 BC means from 600 to 699. This is 720. 720 plus something it cannot take. ABC cannot take any value greater than or equivalent to 6. So let us check whether it is giving you 5. So what we'll do is, to get this value, let us keep one value lowest and another value highest. So this will become 1 factorial plus 5 factorial plus c factorial equivalent to 150. This value we require. 1 plus 120 is 121. 121 plus c factorial equivalent to 150 something. So let us see. C3, 3 factorial is 6, 121 plus 6 is 127, 4 factorial is 25, 145. So I think 145. So if I alter the digits, this is nothing but 1 factorial plus 5 factorial plus 4 factorial. You can change the digits. So instead of b value 5, this is nothing but c value 5. A1C5. So the value that we got it is 155. Like this, try to check it out with other values. If you are getting, well, good and fine. If you are not getting, then this 145 is one such number. All the 3-digit numbers, the only number that can satisfy this condition is, right, 145. So you can check it out. Suppose if c value is another 5 factorial, 120 plus 120 plus 1, I will get 241. So 241 is not possible. I hope the idea is clear. 145 is one such number. Now this question, a factorial b factorial equivalent to a factorial plus b factorial. I kept everything to the left hand side. A factorial b factorial minus a factorial minus b factorial is 0. A factorial common, b factorial minus 1. Same thing I wrote it in the right hand side. Minus 1 into minus 1, 1. So a factorial minus 1 into b factorial minus 1 is 1. In how many ways can you write 1 as a product of two integers 1 into 1? So a factorial minus 1 is 1. A factorial is 2. So the value of a is 2. Are you all with me? B factorial minus 1 is 1. B factorial is 2. So the value of b is 2. Value of b is 2. You can easily check it out by checking this equation. 2 factorial into 2 factorial is 2 factorial plus 2 factorial. 2 into 2, 4. 4 equivalent to 4. So what is the value of a plus b? 2 plus 2 is nothing but 4. 2 plus 2 is nothing but 4. I hope you got an idea. What I did is, I kept everything to the left hand side. I kept everything to the left hand side and I took b factorial minus 1 common. Idea clear? Next one. Another question. Find all the positive integers m, s and t such that m factorial equivalent to 4s factorial plus 10t factorial. 10t. M factorial is obtained because of adding 4s factorial and 10t factorial. That means m is greater than s comma t. First conclusion. Case 1. I will take s equivalent to t. M factorial will become 14 t factorial. M factorial by t factorial is nothing but 14. I hope it is clear. Just by looking at a question itself, I can say m is 14, t is 13. Because 14 factorial by 13 factorial is nothing but 14 into 13 factorial by 13 factorial. Answer is 14. I hope it is clear. Case 1. Case 1, how many values? M14, S, T13, S13. M14, T13, S13. Case 2. Case 2. SC is greater than T. I will also tell you why S less than T is incorrect. If SC is greater than T, M factorial is minus 4s factorial equivalent to 10t factorial. M factorial by t factorial minus 4s factorial by t factorial equivalent to 10. S factorial by t factorial into m factorial by s factorial minus 4, it is 10. Till here it is clear? Yes or no? M factorial minus 4s factorial equivalent to 10t factorial. T factorial, I took it out in the denominator. Why? Because we know that n factorial by n minus 1 factorial is n. M factorial by t factorial minus 4s factorial by t factorial is 10. Just by looking at these equation only, I can say that SC is greater than t. If SC is less than t, 3 factorial by 4 factorial, I will get 1 by 4. 1 by 4 will give you fractions. Are you all with me? So this equation I will write down again, then I will try to solve it. Case 2. Case 2. This will result in SC is greater than T. Why? Because m factorial minus 4s factorial equivalent to 10t factorial. M factorial by t factorial minus 4s factorial by t factorial, it is nothing but 10. S factorial by t factorial into m factorial by s factorial minus 4, which is nothing but 10. Question is, find all the positive integers. That means it can be written as 10 into 1, 5 into 2, 2 into 5, 1 into 10. For s factorial by t factorial to take 10, s factorial by t factorial if it is 10, m factorial by s factorial minus 4 should be 1. So m factorial by s factorial is 4 plus 1, 5. That will give you answer m value 5 and s value 4. 5 factorial by 4 factorial is 5. M is 5, S is 4. But this violates this condition. This is possible when S is 10, T is 9. So one value you are getting S4, one value you are getting S10. This case is not possible. This case is not possible. Second case, S factorial by T factorial is 5. M factorial by S factorial minus 4 is 2. So this will give you S5 T4. Am I right? This will give you M value 6, S value 5. M value 6, S value 5. Because M factorial by S factorial is 6. 6 means M value 6 and means SC is 5 here, SC is 5 here. So how many values that we are getting? Here S greater than 2. I got one value. SC is 5, T is 4 and M is 6. Case 1. S equivalent to 2. So what is the value that we got? M 14. M value 14, S value 13. So two values which we got. You can check it out by just by looking at a question itself. We can say that third and fourth are incorrect. Why? Because M factorial by S factorial minus 4 is 5. That means M factorial by S factorial is 9. That means M value will become 9, S value will become 8. If S is 8, it cannot be 2. I hope it is clear. S factorial by T factorial 1 means S1 and T1. These also not possible. So the only value which is possible is M5, S5, M6, S5 to 4. S cannot be less than T. Try to take a value S less than T. S value 2, M value 3. You will realize that you are getting into a fraction approach. Very, very good question which explains you how to find out the values for factorials, right? Depending upon the question, the concept that is used is n factorial by n minus 1 factorial is n. Next. Now see here. I hope this question is clear. This question is clear. I hope this question is also clear, right? Please check all the questions. This value is also clear. I just took 145. You can take it out any other value. If I take B value 5, C value 5, 5 factorial plus 5 factorial 241, but 5 cannot be possible. You can also take any other value. You can check how to do the division. Still lot of questions can be formed. Find the last two digits of a given number. How to find out the last two digits without multiplying. Find the unit digit of the number. Possible unit digits for n are 1, 2, 4, 6 and 0. Very, very good question based on a law of similarity and the generic logic. For your information, this is an exact CAT question. This is a 10 factorial minus 1. How to find out this question just by sheer observation. What is the definition of a factorial? How to find out whether factorial plus a natural number added, whether it gives a prime number or a composite number. Very, very good questions we discussed. What is the definition of a prime number? I hope the idea is clear. This is the first session of factorials. Factorials we will do 3 sessions. Factorials, if possible more than 3 sessions also. Session 1, session 2, session 3. 1, 2, 3. 1 I covered, which is nothing but basics. 2 I will discuss the highest power. 2 is the trailing zeros and another advanced level questions. I hope each and every concept is clear. If you are enjoying my YouTube live classes and you are